GCF, or greatest common factor. This is the simplest kind of factoring, and this is where we get to factor a single term or a monomial from the whole expression. The first thing we're going to look for is the GCF of the coefficients. Remember, the coefficients are these numbers multiplied by the variable expressions. So in this case we have coefficients of 8 and -4. Just looking at the numbers, not the signs for now, I can see that 4 is the largest number that's a factor of both 8 and 4. So 4 is going to be the numeric part of my GCF. Next, I look at each variable one at a time, and I want to take the smallest power of that variable. So here I have x to the 4th and x squared. My smallest power of x is x squared. Looking then at my y factors, I have y to the power 1 here, and I have y to the power 2 here. Y to the power 1 is my smallest power of y. So if I put all of this together, I have my whole GCF, which is the largest thing that I can factor out of every term. It's 4x squared y, and then I start my parentheses. And to figure out how I fill in the rest of this, basically what I'm going to do is take both of these terms and divide each one by the GCF. When I divide, I'm going to divide the coefficients, so 8 divided by 4 would give me 2. X to the 4th divided by x squared, I would use the quotient rule on and subtract the powers. 4 minus 2 is 2 factors of x. And y to the 1 divided by y to the 1 would leave me just a factor of 1, which I can leave out. For my second term, I have 4 divided by 4, which is 1, so a coefficient of 1. X squared divided by x squared is another factor of 1, and y squared over y gives me y to the power 1, so I still have a y remaining from that term. Instead of dividing, it also works to think of it as pulling 4x squared y out of each of these terms. So think of it as if I started with 4 factors of x and I took out 2 factors of x, I would have 2 factors of x remaining. Similarly, over here on this last term, if I started with 2 factors of y and I took out 1 factor of y, then I would have 1 factor of y remaining. So this would be my factored form, and I can always check my answers to these by multiplying. In this case, because we took out 1 term, multiplying this back out is just the distributive law. Multiplying 4x squared y by 2x squared gives me 8x to the 4th y. And multiplying 4x squared y by minus y gives me minus 4x squared y squared. When I compare to my original, I can see that this is the same polynomial that I started with, so I know that I did the factoring step correctly. Keep in mind that checking something by multiplying doesn't catch every possible kind of error. It's still possible to have not taken out the largest possible GCF, for example. And as long as you did the factoring process correctly, then the check should still work when you go back to multiply it. However, it is good to at least be able to check that process because there are a lot of opportunities for sign errors and such that can happen there. Speaking of signs, we have another convention that if the first term of our polynomial is negative, then the GCF should be negative also. So on this next example, we can see that our first term is negative. So we're going to factor out a negative GCF. I start with the sign. I then look at the numbers 6 and 11. I see that they have no common factors, so I can't factor out a number other than -1. And I next look at each variable one at a time. Starting with the x's, x squared is present in both terms, so I can factor out an x squared. Going on to the y's, I have y to the power 1 and y to the power 2, so I can factor out y to the power 1. And at the z's, I have z to the power 2 and z to the power 1, which means I can factor out z to the power 1. Okay, now I'm ready to factor this minus x squared yz out of both terms. Also note that anytime you factor out a negative GCF, you're going to see all of the signs change in the polynomial that you're factoring out of. So in this case, we have two terms. We're going to change the signs of both of these terms due to the fact that we are factoring out a negative GCF. So that leaves us with now positive 6, and z is the only variable factor remaining from the first term. For my second term, I started with positive 11. I'm now going to have negative 11 as my coefficient. And x squared, y squared, it looks like I still have 1y remaining after taking out 1y. I took out my z, so I no longer have a z. So note that anytime you have a negative GCF, it will change the signs of all of the terms in your polynomial. You can verify that by checking again by multiplying. You'll see that when you multiply that negative sign back in, the signs revert to their original. For our final example, we have a polynomial in 3 variables, but first we note that there is no y in the last term. And that means that we cannot factor y out of the polynomial at all. It still works to say that we're taking the smallest power of each variable, but we would have to interpret that as this being a y to the 0 term, so we take out y to the 0, or we take out no factors of y in this case. So my GCF here, looking just at the numbers first, I'm going to take out a 5. Then looking at my x's, it looks like x to the power 1 is my smallest power of x. Then looking at my z's, it looks like also z to the power 1 is my smallest power of z. So remaining from the first term, I have xy. From the second term, I have minus yz. Sorry, that's minus 2yz. And from the last term, I have plus 6xz. So this would be my final factored form.